Do you all find where it is? Okay. Ha, I have so many colors, I'm happy, right? Yeah. Okay, what is missing? Our step one. You guys with me here, you know what I'm talking about. Lone pair. Okay, who is missing lone pair?
Oxygen.
Should have 2 pair of lone pair, right? Okay, who else is missing lone pair?
Nitrogen.
Should have 1 pair of lone pair. Okay, perfect. You guys are on top of that. Okay, resonance should start from either electrons or bond, right? Okay, in this case, we have several space that we can start either double bond or oxygen, the lone pair. This is also bond. This green, oh, I'll use purple so it's different, okay? It's also a place to start, right? So we have several places. I will start with one of them, which your quiz one asks for who is the major contributor, where oxygen is more electronegative, right? So we kind of like want to make oxygen negative in this case. Could be one of the way, right? But your route of thinking this is now you're good with what is missing. You're not good with what to start. You should also think about where is that a more happy conformer or something like that. And one of the rules would be if you want your oxygen to be the most electronegative charge to take the negative, right? Okay, it's on my notes 3. Okay, it's on my notes 3, back page. Okay, if you are not sure what I'm talking about, back page. Okay, all right, so I'll do this here. And that would give me a resonance structure. I'll write on this side, okay? I'll write on, because later we're going to assign hybridization. Okay, my nitrogen is now double bonded with carbon. And because my nitrogen is bonded with 1, 2, 3, 4, 4 thing, so should has a positive charge in this case, right? And then my oxygen, okay, lose its purple bond. My oxygen lose its purple bond. So I can still keep my original light green, but now the purple bond turned to be a pair of lone pair, and in this case form a formal negative charge, right? And we do one resonance so far. The hybridization assigning in this case has something to do with the resonance, where, okay, I know it's from here, based on what you learned in the discussion. Okay, what was start to assign hybridization? Okay, based on what you learned in your discussion, you learn. Okay, let's see if we're on the same page with that. Okay, I believe your TA will teach you this way, or okay, you will learn. Okay, if it's one bond, okay, one bond. Okay, number of bond. Okay, number of bond. Okay, 1. Your TA probably will teach you, okay, that's a sigma bond, okay? And if you have 2, it's a sigma bond with 1 pair of pi bond, okay? That's probably what your TA teach you, right? In your discussion with a lot of orbitals and showing, okay? If you're not sure what I'm talking about, it's the week 2 discussion where there's like a join the p orbitals like this, okay? Right? Okay, and then you also have some little, I'm not sure if your TA teach all this, but that's on your discussion manual. It's like on your discussion manual, you have a drawing of this. This is the pi bond, and this is the sigma bond, kind of like things. And that's on your discussion manual. If you remember, you're seeing something like this, right? Okay, so that's not really with hybridization though, but it's kind of like your TA says, okay, sp3, sp2, or kind of like things like that. If you just, most of the time it works for your assigning hybridization, but not in this case, because if you just follow that, your nitrogen is only single bonded. Looks like this nitrogen should be sp3, but it's not. In this case, because of the resonance structure, your nitrogen is actually double bonded with this carbon. Your nitrogen is double bonded with this carbon. So this nitrogen should be sp2, okay? Most of the time, what you TAT2 works in the discussion menu, which I'll, yeah. Okay, I remember to bring marker, but I forgot. I'll steal an eraser, okay. Can someone steal an eraser for me? Yeah. Thank you.
I have one you can borrow.
Oh, there are no eraser. Okay. May I borrow? Oh, there's a eraser. Is that an eraser?
It should be. Okay, cool.
Oh, okay, never mind. Okay.
Are there tissues though?
Okay, yeah. May I have some tissues? Yeah.
I have an eraser you can borrow.
Oh, let me just, guess the tissues. That will work. Okay. Yeah. Okay, then people is going to ask, how about your oxygen? Okay.
So like even in this structure on the left, it's sp2?
Yeah, it's sp2. I'll explain in a minute. Okay, then people is going to ask, how about your oxygen? Your oxygen is sp2, which I get it here, but isn't your oxygen change into a single bond? Should it back to sp3? In this case, it's not, because this is a very kind of like a good way of showing delocalization. So our oxygen, carbon, nitrogen. In this case, okay, if everyone can see, it's kind of like it's your double bond was never solid form on any of them. Your double bond was kind of like a jumping in between of these two. And in this case, all of these are sp2, okay? All of these are sp2. And then that's also come to your question on resonance. When should I stop an arrow? Okay, in this case, I draw two arrows at the same time because kind of like the fact of this three atom, they are sharing this electrons. There only one pi bond is keep jumping from here to here and jumping back. Okay, that's where you show two arrows because you are showing the fact is this three atom sharing this one bond and it's keep jumping from here to here. Okay, where I do know some of you in your problem sets, you're trying to write this. Okay, some of you are asking me, okay, this one, it is correct if you want to write a resonance like this, but usually we don't write that because usually we talk about resonance when you have at least one neighbor can do this jumping with you. Where here, if they're both carbon, they cannot do, yeah.
So could you say that you usually need like at least 3 atoms?
Yes, you usually need at least 3, okay? Are we cool with this?
So like it couldn't jump because it would just create like
Okay.
a carbocation and a negative.
Okay, usually I'm talking about if it's carbonyl, okay? Yeah, so where this are sp3, so sp3 is saturated, okay? Saturated.
So and they're all sigma bonds. So they
Yeah, so this way you cannot jump with somewhere else.
Right.
Yeah, we talk about sp3 block your flow of electrons, right? Yeah.
So like you couldn't make a structure that gives oxygen the negative charge and then carbon the positive?
We don't draw that as resonance, but in the end of your 118b, you will see special occasion of that.
Okay, so that wouldn't have any because they're all.
Yeah. Okay. So that's also related to your homework. Okay. If we're good with this one, okay, here this carbon is also sp2. Are we cool with that? Okay. I'll lower this. I know people are trying to write. Okay. This carbon is also sp2. This is also sp2. This is sp3. Okay, this is sp2. And this is sp2. Okay. If you need to finish, assign the hybridization of all those. Okay, that's a special one. Okay, this is a special one, but it's the point of introducing this type of question is when you assign a hybridization, you should take resonance into consideration. Yes?
So if we're doing delocalization, do we take the resonance for every structure, or is there like a certain structure you take the resonance for?
It's kind of like when you see there's 3 neighbors that can jump, there should be a ring in your head start to start to talk to you. Okay, I should take a resonance. I would say if you need any specific one, treat this one as your first special one. Whenever you see CON, you know that's a combination that's they talk to each other. So nitrogen in this case should be sp2.
Is CON the only combination, or are there more?
There are more, but it's like if you change this N into oxygen, that also works. But it's like don't treat this one as okay, I need to memorize. Don't do that. Your sense is based on see, they're all sp2, right? They're all sp2, which means they can we talk about sp3 block, right? Your resonance. But when you see sp2, you kind of like that's okay. Usually your electrons is jumping with those sp2, so that's also related to your resonance. Okay. So it's kind of like, it's, okay, I'll post the video for now. Okay, I think this one